So Wednesday you learned about probability and finding the theoretical probability and writing it as a fraction or a percent. Today we're going to be able to calculate the number of possible combinations using a tree diagram and the fundamental counting principle. So knowing how to calculate the amount of combinations is really important for the next two lessons we're going to do, and today's going to help teach you how to do that. Okay, so outcome, the word outcome is just final product or end result. So using a tree diagram to count outcomes, to count how many possible combinations there are. So the question says, how many possible combinations does Joey have when choosing between a black, white, red shoes and between yellow, purple, green, or tan hat? So a tree diagram is fairly easy to make. Okay, you start with one of the possibilities. So I'm going to start with the shoes. So there are three options of shoes. He can choose a black shoe from his closet, a white shoe from his closet, and a red shoe from his closet. Okay, then we look at the hats. From there, all right, if he chooses a black shoe, he has four options of hats: yellow, purple, green, or tan. Okay. And if he chooses a white shoe, he also has four options. He has a yellow hat, a purple hat, a green hat, or a tan hat, and you should see where this is going. If he chooses red shoe out of his closet, he can still choose a yellow hat, a purple hat, a green hat, or a tan hat. All right, so that means if I count up all the ends here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Joey has 12 options, okay? And the probability of him choosing one of these outcomes is choosing 1 out of 12. So I'm going to write that as a fraction, and then you should have your calculators open so that we can also use this to write percentages. So 1/12 as a percent. I'm going to do 1 divided by 12 times 100. I get 8.3%. So he has 8.3% chance of picking one option, of picking a black hat with a yellow shoe, or a white hat with a tan shoe, or a red hat with purple shoe. Right, and that's all it is. That's a tree diagram. Like, that's super easy. All right, we're going to try one more as an example. So, Kara went to the Southside Soda Shop for lunch yesterday. She had a choice of soda or juice to drink. Her sandwich could be on a bagel, rye bread, or white bread, with her choice of cheese, pastrami, roast beef, or turkey. How many different outcomes could she have picked for lunch? Okay, so when I have multiple options like this, okay, soda or juice, bagel, rye bread, or white bread, cheese, pastrami, roast beef, or turkey, I'm going to actually start with the most options I have, and then my tree diagram, I just won't have to write as much. So I'm going to start with the choice of like cheese, pastrami, roast beef, or turkey. So she can choose cheese, pastrami, roast beef, or turkey. Okay, she has four options there. Then I'm going to go to the next smallest. So if she chooses that, she has three choices of bread: bagel, rye bread, or white bread. And we can do the same here: bagel, rye, white. Bagel, rye, white. I did not leave myself enough room. And then same here, all there: bagel, rye, white. Okay, and then from there, she has two choices of something to drink: soda or juice. So if she chooses cheese on a bagel, she can choose soda or juice. So every one of these options is going to have two options off of it saying soda or juice. And this is going to take me a really long time, so I'm not going to write all the things. You should. But all of these options have two options off them: soda or juice, soda, juice, soda, juice, soda, juice. All right. So then I have to count up all of those options. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there are 24 combinations. And the probability of her choosing one of these, so like her choosing turkey on white bread with soda, all right, is like 1 out of 24. And then if I write that as a percent, right, we're going to divide 1 divided by 24 times 100. I get 4.2%. Okay, so the more outcomes there are, the smaller the percentage is going to be. Okay. So I want you to pause the video, make a tree diagram, and see what's the probability of you choosing one of these possibilities. All right, so you should have paused it and you should see that there are 6 possibilities to choose from. All right, and that means we have 1 out of 6 chance of getting that possibility, which is 16.7% chance of ordering like deep dish pizza with sausage on it. All right, so I'm going to teach you an easier way to find the combinations, but you still need to know how to do a tree diagram. Like, they are still important to be able to write, and it helps you actually see all of the different possibilities laid out. Okay, but there's something called the multiplication counting principle. So if an event has m possible outcomes and another event has n possible outcomes, then there are mn, so m times n possible outcomes. So what that means, okay, is, for example, this problem. So the cafeteria offers 3 different meats, 4 different vegetables, 5 desserts, and 2 drinks. Right? That's a lot of options. So making a tree diagram is going to be a pain. So instead of having to make one, okay, you can multiply all the different options together. So there are 3 meats, 4 vegetables, 5 desserts, 2 drinks. If I just multiply this all together, so 3 times 4 times 5 times 2, right, I would get how many different meals consisting of 1 meat, 1 vegetable, 1 dessert, and 1 drink are offered. So that would give me 120. All right, and making a tree diagram with 120 outcomes it would just take forever, all right? But so you can multiply them together. So there's 120 different options that the cafeteria offers. Okay, same thing here. We're going to do the same thing. I want you to try it and then check back your answer with me. All right, so you should have paused your video, you should have calculated it out, and you should get that there are 30 options. So there are 2 options for president times 5 options for vice president times 3 options for secretary. So that would be 10 times 3, which is 30. So 30 total options. Okay. So what about this? How many different combinations are possible if 2 coins are flipped and 1 dice is rolled? So this is where it gets a little bit more tricky, I guess you could say. So if 2 coins are flipped, that means on the first coin, okay, I have an option of heads or tails. Right? So I'm making this into a tree diagram so you can see the possibilities, but I will show you a different, easier way to do this in a second. Oops, I did not mean to do that. Okay, so there on the first coin, you have the option of heads or tails. from there, so like that's, why do I keep doing that? That's the first thing that's going to happen. I'm flipping for heads or tails. Okay. On the first coin, if I flipped a head, the next thing I can do is flip a head or a tails because I have 2 coins. Same with the tails. If I flipped tails first, I could next flip heads or tails. Okay, from there, off of each of these options, when I roll a die, I have 6 options. 1, 2, 3, 4, 5, 6. Again, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Okay, so like one particular option was I could pick, like I could flip a tails, then I could flip heads, and then I could roll a 2. Like that's one option. Or I could flip a head, and then I could flip a tail, and then I could roll a 5. That's another option. Okay, so then I count all of the ones out here, and that'd be 6, 12, 18, 24. So there are 24 combinations. Okay, now a tree diagram just helped me visualize what was happening, but you can also just use the multiplication counting principle. And so what that is, I'm just going to not erase it nicely. What that means is there's 2 coins flipped and 1 die roll. So on each coin there are 2 options. So the first coin, there's heads or tails. The second coin, there's also heads or tails. And then there's 1 dice being rolled, that's 6. So 2 times 2 is 4, times 6 is 24. So that's another way to figure out how many combinations there are. Okay, next, what is the probability of getting tails and a prime number? I shouldn't have gotten rid of that tree diagram. Okay, so I'm going to rewrite it real quick. Okay, so I rewrote the tree diagram. So probability of getting a tails, that just means any of these have to be tails, and a prime number. Prime numbers are numbers that can only be multiplied by themselves or 1. So that would be like 1, 2, 3, and 5 are all prime numbers. And actually thinking about that, I don't think 1 is actually a prime number. So the only prime numbers that are out there are 2, 3, and 5. Okay, so next I'm going to look where I have a tail, at least 1 tail, and 2, 3, or 5. So this is my first option. There's tails. So I can go this way and this way. So 3, 2, 3, 5. Okay. Also, tails and tails works because it's still a tails. 2, 3, 5. Now, if I have a heads and I roll heads, I'm not getting a tails, so I can't go that option. But if I roll heads and I roll tails, I can go that option. So 2, 3, 5. So how many have I circled? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability of me getting a tails and a prime number is 9 over 24. Okay, which as a percentage, because it's really, we want to see percentages because it's just easier to understand sometimes. So as a percentage, 9 out of 24 is 37.5%. So it's not a great percentage, but it's not a bad percentage of being able to flip a tail and a prime number. All right, so you're going to practice this worksheet. I would write your answers on a separate piece of paper and turn in that paper because you have to draw tree diagrams, so you can't really type in the answers. If you have questions, email me.